Good evening. Hello. Good evening. Hello. Welcome to Milliways and the evening the evening talks at Milliways on day 3. I hope you had a great day already and we'll have a much greater day even in the evening today with nice talks. The next talk will be held by the network team of the Tor project, and they will present us with a guided tour through Tor networking health and performance.
Thanks everybody for coming. We have collected a little group of people from the Tor project here who's going to talk a bit about general network status thing, and particularly with focus on the health and the performance that we've been working a lot on in the past few years. So I'll just do a quick introduction of everybody. I'm Alex. I'm heading up Tor's network team. We're the team responsible for writing the C Tor implementation and the Rust implementation that we'll be talking a little bit about, called Arti. Then we also have Yuga on stage. Yuga is one of our bandwidth scanning experts and worked together with Georg, who is the network health team lead. Finally, we have Gus, who is heading up our community team and is doing a lot of the engagement with people in our community and the Relay operating community and so forth. So if we start out with talking a bit about some of the features we've been working on for the currently stable Tor release called 0.4.7. One of the things we built in that was congestion control. Tor had originally not had any sort of good mechanisms like we see in TCP with regards to congestion control and handling congestion in the network, which led to a higher variance in sort of error conditions when you were using Tor and the performance was not so good. So what the team did was that we evaluated a number of different options for congestion control algorithm. People who are into some of these TCP things might notice some of the names are similar. They're very related from sort of the general network world. The three system we looked at was called Westwood and Vegas and NOLA. While the team was looking at it, Google also came with a paper with a congestion control system called BBR. But many of these systems suffered from some issues that led to these runaway congestion conditions, which made them unsuitable for what we were trying to do. We ended up spending a lot of time working in a simulator that we have called Shadow, where we tried to test the different algorithms for seeing how they were performing, having an idea about which parameters we could tune in various conditions, and see how things are doing. These plots are a little bit difficult to understand. They're CDF plots, but the idea here is that the orange part of the curve is the 0.4.7 release, and the blue part is the 0.4.6 release. And the left picture is a simulated instance where we try to behave like we're a client being in Germany, and on the right-hand side we see one in Hong Kong. And what basically these things tell is that we see a higher amount of the traffic being performant for the new system. We are sort of moving towards this new release that are coming very soon, where we have then decided to remove some of these algorithms because they're simply unused, and Vegas is the only one currently that is left. We will continue to tune on these things. We will learn as more clients are coming on, as we do various upgrades in the network, so we would likely have to tune different parameters. And the entire system is made so that the directory authorities, which is the nodes that are sort of the trust anchor in the Tor system, will be able to tune certain parameters based on various like ideas or experiments we want to try out. So all of this sounds good, and many people will sort of say, okay, is it then going to be super performant, or how is it actually going to change things? As some of you may know, we have had a denial of service going on the network for quite a while. So I'm trying to show this using some fairly old plots, and then show it with some very current plots after the network has upgraded to the 0.4.7. So if you look at this one, this is the time to complete a 5 megabyte download to a public server over the Tor network. As you can see, the variance is very, very high in this. We have some error conditions where it took up to 50 seconds for for sort of these requests to go through, and most likely the user will have abandoned the web request that was happening there. So after we deployed congestion control, it now looks like this. We're down to having sort of a 20-second boundary on this, and it's starting to look a whole lot better, and you will likely also experience this when you're using Tor browser in your daily life. Because ideally, requests should go through quickly, right? I believe there's a lot of you in this room, or on this stage, that is operating Tor relays. A massive thank you to everybody who upgraded to 047 very, very quickly. Yes, big round of applause for that. It is so important that when we get releases out, that they get deployed to the network, because many of the releases that we make requires us to upgrade the network before we can start upgrading the clients. So before we can start including these features in, for example, Tor browser or other applications that uses Tor, then we need the network to be upgraded. So huge thanks to everybody who's been doing this. We, I think last week, I've been camping for a while, but last week we released the release candidate for the Tor 048. Just like with 047, which had the congestion control feature, there's some pretty important features that I'll be talking about in a moment, which is coming out in this release. So we really hope that people will be very, very snappy with upgrading quickly again, so we can start testing these things out on the live network. So one of the big features that we are adding in 048 is very much related to this denial of service attacks that we've seen. The nature of the denial of service attack is not so that there is one denial of service attack. We've likely seen many different kinds of attacks that's happening within the network. But sort of because of the design in Tor, we can't really go in and say and pinpoint what exactly is happening. But we know that some of the attacks is happening towards onion service traffic, which means that it stays within the network and never goes out over the exit nodes. So one thing we've implemented is that we have implemented a proof of work scheme. Some of you know these from blockchain projects and how they are burning down our planet. This system is designed in a way so that by default it's not enabled, but the onion service, if it sort of realizes that it's under attack on various network conditions, seems bad, it can enable it and slowly sort of increase the sort of difficulty that is used for clients to connect. We have chosen a scheme that we got help from a contributor called C Tor. Great thanks to them for working on this. If you're interested in sort of the technical details about how this scheme works, we have this proposal called 327, which includes all the technical aspects for how to implement it. And as of last week, I believe, we also have the documentation ready if you are operating onion services for how to use this feature and testing it out in your production system. There is one slight catch with this proof of work scheme. It uses quite a lot of memory, which means that particularly for Apple's very closed iOS platform, we are likely not going to be able to enable it. It's Guardian Project who's doing the Orbot for iOS. And because of Apple's network extension memory limits, we are very unlikely to be able to support it there. But the effect will likely be the same as if the feature was not there, namely that if there is an error condition happening for the given onion service, then the client will simply not be able to reach it, and this will just impact iOS users more. If you know anybody who works for Apple, then please ask them to bump this limit. It has been bumped a few times, but it's still a bit too low for us at least. The big feature that is going to come in 048 is a feature called Conflux. Historically, most people in here is probably aware of that when you have a torrent circuit, you have the client which connects to a guard node, and you extend it to a middle node, and then finally to an exit node, where you then make your TCP flows out to the internet. One of the API features that we have now inside of Tor from the congestion control system is that we can get information while the traffic is being sent and received on how congested the link is. This allows us to utilize this Conflux feature to create multiple legs into the network and sort of rendezvous at the exit node. And then the client can learn which of these two paths through the network is the least congested and switch over to transmit and receive on that one. So hopefully, now that we have seen with the congestion control part that we have gotten the variance of errors and delays down, then we hope with Conflux we'll see sort of a greater performance when you're downloading larger things and using the Tor network in general. One of the really nice thing with sort of this whole performance project we've been running in the network team for a while now has been sort of how the team has been working together and developing things. We have historically used this tool called Chutney. It's sort of a little Python thing where you can say, give me a Tor network with 400 nodes, and it then starts 400 Tor instances on your computer, and you can test things. We also have a system called Shadow, which is like a more powerful simulator where you can sort of simulate a whole Tor network and including having time change. So we can, for example, simulate a year's use of the Tor system over like a couple of hours, and we can even do it in our CI toolchain, which has been really, really awesome. One really nice thing with sort of how we work like many research projects, so we get grants to do our work. We often these denial of service conditions that happens have this impact that we need to drop everything we're currently doing of deliverables and switch over to doing mitigating the attacks. We fortunately now have a sponsor where we can do some of this work on denial of service if something comes up, and if we need to tune things or if we need to come up with new mitigation techniques. For people who are sort of nerding out on our GitLab, then these things are tracked as, like GitLab has this label thing, and we have a denial of service label, and we also have a sponsor 112, so if people are interested in seeing what kind of things we are planning, you can go look there. How many people in here have heard of Arti? Okay, not so many. Arti is our attempt, hopefully it's going to be successful, with trying to write a Rust implementation of Tor that will eventually replace the C implementation. One of the issues that exist with C Tor is it's a very old application by now that has sort of evolved over time. The architecture of it is not really fit for sort of the modern day world, where how we do applications, how we have mobile applications and so on. So Arti will become primarily an API for working with different kind of Tor objects, like the network documents and making circuits and these kind of things. And it will eventually allow you to both build a Tor binary like you're used to having today, where you can connect over a SOX port, but it will also allow you to have a Tor implementation embedded into your applications if you want to do certain things. And finally, it will also, of course, support onion services. It's not a sort of an easy decision to make that you want to rewrite, like throw away so many years of work and then try to rewrite it in another language. We do some assessment on our issues, when we have issues that we consider that they have such severity that they would be considered security bugs. And we could see at some point that 21 out of 34 of what we call troves, they're a bit like our internal CVEs, where we have some different categories that we use, would be highly unlikely to happen if we were using more memory-safe languages such as Rust. Another big component of this is that the network team at Tor is much more excited about Rust than they are with C, and developer happiness is fairly important as well. If we look a bit at the roadmap for Arti, we are now at the point where we are working on onion services. We've just entered the year 2 funding for this. There's already stuff that if people want to try around with, having sort of a little Rust library where you can build onion services, then you can start trying it out today. The goal is that when we are at the end of this year, the browser team at Tor will start to be able to play around with embedding Arti into the browser. We are currently working on getting funding for building relays and bridges and directory authorities and all these sort of things that are hosting the network. But for now, we are sort of focusing on the client side, because the way Tor is designed, the client side is sort of the difficult thing to build. Right now, it's almost the majority of the network team at Tor is working on Arti or Arti-related deliverables. We also have a little VPN project that we're experimenting with that is also getting some attention. We hope to very soon have sort of the entire team focusing on this. We're currently 3 people out of 10, I think, that is sort of left focusing on C Tor. What you will most likely see is that we will start limiting client features, so only do the things that is needed to upgrade the network, and then do the client features primarily in Arti itself. One of the big things we want to work on soon is UDP, for example. UDP will have a network upgrade in the C Tor implementation, and then it will have feature support, client feature support only existing in Arti. We will, of course, continue to support C Tor until we're ready to replace it. It would be crazy to do anything else. If you're interested in tracking some of these engineering efforts that we're doing, I believe that one of the nice things we have with Arti is that it will probably be easier for more people such as yourself to contribute. The C Tor code base was a bit difficult to get sort of wrap your head around when you were just diving into it. We have an IRC channel, Tor Dev, on the OFTC network, and we also map it over to Matrix as Tor Dev. We have our GitLab account, our GitLab instance, where you can track the engineering efforts and what we're doing and so on. If any of you are interested in this, you're also welcome to come and find me here at camp and talk a bit about these things. Now I'm going to pass the mic to Yuka, who's going to talk a bit about bandwidth scanning.
So bandwidth scanners, we need them to monitor the Tor network performance, to better distribute the load across the network, and to help to verify relays bandwidth. Because the relays themselves report the bandwidth they see that pass through them, but there are no other relays to verify them, to verify that. So how it works? The scanner builds two hop circuits between the relay that wants to measure and another relay that helps to measure this relay with double bandwidth. Then download data through this circuit and write it in a file. Every hour, this file is read by the directory authorities, and they vote on the consensus weight. This is a graph of the number of relays measured by the bandwidth scanner by each directory authority in the last 4 days. What is new now is that we have also a bridge scanner. The bridge scanner works in a very similar way, but it creates 3 hops circuit. This helps with the users to have a better experience, because now, instead of just distributing the bridges that are available, the bridge authority is distributing the bridges that which bandwidth ratio is over a certain threshold. And this is a graph about the measured bridges in the last days. The ones that were accepted over that ratio and the ones that are not. Oh. And then Gecko is going to talk about more network health things.
Thanks. Looks good. Thanks. All right. So you heard already from Alex and Hugo a lot about the performance angle of network health work. But as you might know, there are many more things we have to consider once we want to think about whether a network is in a healthy state or not. So we have a project Alex has been mentioning already, which we are currently focused on, which is trying to defend more effectively against malicious relays, which is a considerable issue for the Tor network for a long time. You might have heard about this. You can see the nitty-gritty details in the blog post I wrote a while ago. But having malicious relays on the network is definitely not good for the health of the network overall. So what we want to do is improving the state of the art, which is currently deployed and which we currently have as tools. But that's only one of the things which needs improvements, because as we have seen over the years of fighting malicious relays, just setting on and having more and more sophisticated tools to find and hunt down and kick out malicious relays is not going to fly over the long run. There's no way to win this arms race in that way. We have to have a kind of a social approach as well, a different tool in our tool chain for defending against malicious relays that way. Gus will talk a bit about that, what we have in mind and what we plan in the next couple of weeks and months. But that that's an important thing to keep in mind. There's no technical-only solution against malicious relays in the Tor network, and we are working on that part, getting this right. And the other important point when you're thinking about network health is that there are a lot of relay attacks which we have seen. Over time, over the years, in practice and mentioned in papers. We never found time to actually address those in our day-to-day work. We got funding for that. I talk a bit later about what those attacks are we have in mind. Alex mentioned already one, which is the DDoS one, which is a really hard one. Because we have seen in this year DDoS attacks, which were kind of 4 different DDoS attacks coming to the network at the same time, and all 4 of them would have needed totally different approaches to tackle them. One, Alex mentioned already, the proof of work thing, and there are other ones, but we want to make progress on those things as well in this upcoming work. And the timeline for the project was October 22 to October 24, though we are kind of in the middle of where we are with the work on this part. We have actually to dig a bit deeper. It's not just fixing tools for detecting malicious relays or fixing those attacks. We have to redo our metrics pipeline as well. The reason for that is it's not, as I said, it's not really enough to have tools for detecting malicious relays and then kicking them out. Sometimes we have seen really persistent attackers in the network doing attacks over a month and sometimes 1 or 2 years. And we need to detect those things earlier, and we need to do those detections by not having only compressed tables of descriptors and consensuses and whatnot over a month and years as we have it now, because that's really cumbersome to work with and slowing things down. So what we want to do is we want to redo our metrics pipeline in a way, as you can see on this picture here. So we have a downloader which is downloading all the different descriptors and macro descriptors and consensuses. And it's writing things in an archive, and at the same time it's putting things in a PostgreSQL database and then a Victoria Matrix piece, which is helping with the time series. And then we want to do a RESTful API written in Rust, where we can query stuff and having some shiny Grafana dashboards where you can easily see how things are going on. This is not just meant to be for our internal usage, but of course at the first time we will be the ones dogfooting our stuff, but we plan to somehow expose this to interested operators and the wider community as well, where they can dig through the data and come up with issues in the network we might not see, and just play with stuff around at some point later. We'll see how this goes. At the second point we want to do while we are working on this project in the metrics area is we want to build a small service to annotate our knowledge of the Tor network, and this tool is called C Tor. And it's basically like a relay search we have right now. If you go to metrics.torproject.org, there's an option to look at the state of your relays via relay search. And what we want to do here is we want to add a little node or a category to Tor routers, where we can keep state of Tor routers, which would, for instance, say, hey, maybe Gus knows the operator, or maybe I am knowing the operator, or maybe Roger knows the operator, and maybe you can annotate and say, hey, I've met this guy at the camp or at DEF CON or whatever. So we can see a bit first how many of the operators we actually know, because nobody is knowing this nowadays. And then we can ask, I know these number of operators, and we can think about, hey, how many of the capacity of the network do I actually know, by operators, and this kind of stuff. And this allows us later on to build actually tools for our bad relay work on top of that. Because we mentioned some of those. One thing that got mentioned in the past is we could say, okay, in order to minimize the risk for our users, we could just cap the total amount of access capacity a single operator can run in the network. Right now, it's not really a thing embedded in the code. It's kind of operators contacting us and saying, hey, I'm now running 10% of the access capacity. Is that okay? Or should I maybe do something else? Because it might be exposing too much risk to your users. And but then we could think about building a thing where we say, okay, maybe it's just allowed for access operators to run 5% of the access capacity, or maybe just 10 or whatever. But first of all, we need to know how many of those folks we actually know to have an idea of how many people we trust in the network by now. So for the relay attacks, here are some of the things we could think about, and we are actually thinking about. You can find more details in this GitLab milestone, where we have a detailed description of the things we want to work on and managing those attacks. There are relay side channel attacks we have seen in the past, where users got de-anonymized. We want to investigate and finally fix tagging attacks, where we try to manipulate the routes of the network users can use, not we, but attackers can use, and we try to defend against that. And those attacks already got mentioned. We have some traffic analysis papers, resistance papers seen in the past, and we want to implement the most promising things from them into the code we have. And then there are bandwidth inflation attacks. You might recall Hugo talking about the bandwidth scanner. One of the ideas was at some point building a bandwidth scanner, which is actually not really only measuring the bandwidth, but detecting once relays try to claim they are able to relay more traffic than they actually are. Because there might be people around saying, oh, I just set up this relay, and whenever a user is coming, I just give it a really crappy service, trying to minimize the cost I have for running a relay. But once the bandwidth scanner is coming and measuring my relay, I show there's a really big bandwidth I have available. And that's why I get a higher consensus rate, which means more users are picking my router in the circuit. And this kind of cheating and attacking the network we want to avoid at some point. And there are ways we can do that actually, and we are working in this project moving forward in this direction. So I think that's it for me. I pass the mic to Gus for the final part.
Hello. So this is a Tor exit node that is hosted here in CCC Camp. Thanks Article 10 for her running this relay. So I'm going to talk a little bit about the work that the Tor community team is doing. First thing that we need to acknowledge is that Tor, as an organization, we developed the software. As you see, Alex talking about the complex stuff about Conflux, congestion control, algorithms, Giko and Huga talking about network health. But there is one very important component that is the community who's running the software. Like without relay operators, we don't have Tor network or we don't have Tor, right? So the idea of this to mitigate the attacks against Tor, the idea is to improve the network health, the community health of the Tor network. So we talked before on building tools to fight bad relays, like creating scanners and this kind of stuff. This is one way to fight bad relays, but the other way is also using the social approach. So instead of running scanners, this is also we are going to do, but the idea is to have a community that we know, so we can say, oh, this person that is running 100 relays, we know them, and they are cool people. So the idea is to make the community harder for infiltration. So one quick question, please raise your hand if you are running a Tor node. Okay, I can see some people. So according to our specialist on Twitter, called X, brew, the NSA controls a significant amount of Tor exit nodes, something like 90%. I don't know how accurate is this. I love the day I heard the stats. Nothing is truly safe. So according to this random person on the internet, 90% of people here are paid or are part of NSA, right? And this is ridiculous. So we can see part of the network health discussion on the internet is very low. Like people do randomly do claims about who is running Tor relays. And this is something that we want to change, not about their reputation, but also about like knowing the community and showing the work that people are doing is also rewarding. Like people can want to be seen, like, hey, I'm contributing with the Tor network 10% of the exit capacity or 15% of the exit capacity. And this is very important, you know. So there are many adversaries against Tor, but there are, I believe there are two extreme positions that are not helpful on this debate. One is underestimating the problem, like, well, everything's fine, please don't remove my super sketchy relays. They are just happy relays. So we have this kind of attitude. And the other one is like overestimation of the problem. Like, oh, well, the CIA is running the whole Tor network, so I'm going to use this other solution here instead of the Tor network. And this obvious doesn't a good solution, right? So one thing that we have been working to mitigate this problem of trust on the Tor network is to create a process involving the relay operators. One, hello, hello, is working? Hello, okay. So we have a process involving the Tor community. So the idea is to have relay operators to submit proposals or ideas or comments or suggestions, how we can improve the Tor network and how we can improve the health of the Tor network. We wrote very recently a meta policy where you can understand how is the process, how you can submit a proposal to improve the Tor network health. So some examples of proposals. First example, a guideline for maximum consensus that Giko was talking here. Other thing was allow a limit total consensus as a fraction by family. So if you are running a family of exit nodes, you can only run 10% of the exit capacity. No matter what, if you add 100 more relays, it will always be the same. This is a proposal, it's not approved. We are evaluating this kind of ideas. And also we have another proposal, like another example of proposal of how you can conduct open source investigation when you're hunting malicious relays. So one problem that sometimes we have, people report that a relay is bad, but when we ask them like, okay, how that relay is bad, what they are doing, the person doesn't explain how they came up with that result. So if we cannot reproduce that thing, we cannot say that's a bad relay, right? And if you look, for example, in Twitter and social media and other places, you can see like sometimes people saying crazy stuff about exit nodes or relays, saying like, well, this exit node is clearly malicious because you can see by the contact info. And sometimes relay operators are very funny people. They sometimes create names of their associations as CIA about confidential integrity and authentication. So sometimes people are very funny and users are not, they don't think that's a funny thing. So this is why we the guideline to have to help people to do open source investigation. So because Tor network is a public network, we should expect that people are checking their relays, right, and see the behavior of these relays. Another example of a proposal that was recently submitted from the community, like we have a limit of how many relays you can run by IPv4. So before was 2, and the idea was you cannot run with one single IPv4 address, you cannot run 1,000 relays. So to avoid this kind of attack, it was limited to 2. We bumped that number to 4 because some relay operators wrote a very nice proposal saying, hey, the IPv4 is very expensive, and we have hardware, we have capacity, we have bandwidth. The only thing that we don't have and very expensive is to buy IPv4. So the idea was, okay, we can bump to 4 and see how the attackers are going to act, what's their behavior. If everything is fine, we can bump to 8. So right now, you can see that we have, you can run 8 relays per IPv4. And that created a very interesting graphic here. You can see that before this proposal, we were like 1,500 relays, exit nodes, sorry. And now, after this proposal was approved, we have now almost 2,500 relays. So this is how a policy made by the community and endorsed by and enforced by the Tor project, this is how we can change the Tor network. Right? So sometimes we believe, oh, how we are going to increase the Tor network capacity, or how we're going to make more people to collaborate, or make the Tor network faster. Sometimes it's not an engineer thing, but also a policy thing, like something that we can change on the Tor code, something we can change on the Tor network. So the next activities that we have here in the camp, tomorrow we have the Tor Relay Operator Meetup. You don't need to be running a relay to join this meetup. If you are interested in Tor, if you have questions about Tor, or Snowflake, or other pluggable transports that we didn't talk about that today, well, you are welcome to come and ask about this. It's going to be on Bornhack Village at 4 p.m. And you can also check this very cool project from Article 10 on their village. I don't know how to pronounce it in German, so I'm not going to dare to pronounce this. And you can check their exit nodes and make questions. Like Article 10 is one of the largest exit operators on the Tor network. So if you think like, oh, NSA is running a bunch of relays, actually it's probably Article 10, nothing to hide. That's an operator from Netherlands. Many other operators here in Germany. So you have opportunity here to, I believe, meet 40% of the Tor exit capacity. So if you walk around and talk with people, you are running the Tor network. And we have another campaign happening with Electronic Front Foundation called the Tor University Challenge. It's university, but means education. So if you have a school, if you have an education project, you can join this challenge. The idea is to have more universities running relays. And you can see in this website how many universities are running relays. And if you want to be part of the Tor community, like running relays, there are other ways to contribute with the Tor project, like doing trainings, translation, etc. But you can also join as an operator. We have a mailing list that is open, and you can subscribe. We have the Tor forum. It's a very easy tool for newcomers to join and talk and ask questions. We have Matrix and IRC to chat with us. And we have monthly online meetups that are announced on the Tor Relays mailing list. But if you cannot run a relay, you can also run a Snowflake proxy. Again, we have more than 141,000 proxies of Snowflake, which are very important right now for people in Iran to access the free and open internet. And to run a Snowflake proxy is very easy. You just need to install an add-on on your browser, and you can help people. And very curious that Germany is also the top largest country contributing with Snowflake proxies. So again, thank you for running a bunch of Snowflake proxies. And I think that's it from me.
Great round of applause. A great round of applause for this tour through Tor networking. We now have an open mic. You can queue up here for a few questions. So, if you have a few questions, please queue up back, around the back, please. Not running through the camera.
Hey, thanks for your talk. I really do see that the attacks on the network are a big problem, and I find the extra layer of social layer of trust you want to implement interesting. I can see a few problems with that, but I mainly wonder if it might undermine the spirit of Tor, spirit of anonymity, if I have to identify as a relay operator to you, especially in a country where Tor operating might be illegal. Thank you.
Hello? Here. Okay, yeah, so this is a great question about transparency and privacy. The Tor network requires user privacy, and who operates the Tor network, we require transparency. It doesn't mean that we require phone number, identification, legal names, your passport number. We don't require that. We require like a nickname and some way to contact you. So we are not requiring to disclose your legal identity to the Tor project or something like that. So I think this is very important because we wrote recently a document about that, like the Tor relay, expectation for Tor relay operators, which we say running a Tor relay requires transparency. So if you cannot do that, maybe running a relay is not the best way to contribute with the Tor network. Maybe it's running a training, maybe it's localizing Tor, maybe it's teaching others about Tor. So you don't expose yourself to the Tor network because the Tor network is a public network. So if you are at risk, maybe you should not run a relay.
Thank you for these insights into Tor development. Thank you for being here, and I think we can find you somewhere. If we have further questions, find them.
Oh yeah.